Okay, here is the nomenclature problem. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them you're going to have to name. There will be 10 on the test. There won't be these.
Make them the same.
But there'll be 10. What?
Make them exactly the same.
No, there'll be different ones, but there'll be 10. So that gives you good practice because they're going to be representative samples. And you either have to write the name if I give you the formula, or provide the formula if you're given the name. So you should be comfortable going both ways. And the first one is a simple, straightforward, what kind of a compound is that? An ionic compound. We just went over the rules for that. How do I name it? I name it after, what name comes first? I name it after the what? The first element's going to appear first in the formula, yes. But by that conveniently is always going to be the what? The cation. And the cation is always going to be the metal, right? Because this is going to be a theme that's going to carry over when we start dealing with molecular compounds, which are composed of non-metals only. In molecular compounds, we take the most metallic of those, and it goes first. Okay? Okay, so carrying on that theme, so this is strontium, and is it a fixed charge? What group is strontium in? Say it like Lewis Black. 2. It's group 2. So it's got a charge of +2, the group number. And it is a fixed charge. You don't find strontium 1 lying around. It's either strontium 2 or it's elemental strontium. It's not found any other way. So I name it. I give it the name of the cation first. So it's going to be strontium. And then, what is this molecular ion? Yeah, it's an oxo compound. There's only 2 possibilities with the phosphate or phosphite. Phosphate is PO4. Phosphite is PO3. So this is strontium phosphate. Okay. Now, for the next one, I am given the name. I have to come up with a formula. And what goes first when I write the formulas out? The metal or the cation, and that is the symbol K. By the way, this is case sensitive when we give the symbols. So it's always an uppercase K, never a lowercase k. Okay, potassium. Now chlorate. That's one of the oxyanions of chlorine. How many possibilities exist with those? 4. So chlorate being the one with next to the highest number of oxygens. So that's going to be, so it can be up to 4 oxygens. So that's going to be O3. Okay. If it was ClO4, what would it be? Perchlorate. If it was ClO, what would it be? Hypochlorate. If it was ClO2, what would it be? I'm not hypochlorate, hypochlorite. If it was ClO2, what would it be? Chlorite. Okay. So we're all good there. Okay, now this bad boy is so familiar. We've been seeing it most of our lives, and it's present in battery acid. This is battery acid for our lead acid battery. Again, we name, and because it's this aqueous designation, it makes it an, if that wasn't there, what would we call it? It would be hydrogen sulfate, cation, anion. But this molecular anion is the sulfate, not the sulfite. And so that means this is going to be named after the anion, and it is, because it's aqueous, it's in water, we call it what? Sulfuric acid. Okay? Now, iron 3 oxide. Okay? Since I gave you the name, that pretty much tells the tale. What's the charge on the iron? 3. Okay, what's the charge on oxygen? It's the group number minus what? 8. What group is oxygen in? Group what? 6. So what's the charge on the oxygen? Minus 2. And so that means in order for this to be electronically neutral, I'm going to have to find some common divisor. And what was the formula? Remember over here on the scratch paper? If I have a cation with N plus and an anion with M minus, you always go like this. It's going to be cation M, anion N. Right? So what is this one going to be? Fe2O3. Okay? And you should be able to go both ways with these. So practice doing it both ways. Okay, this one's given the formula. Is calcium a fixed charge? What group is it? Group 2. And so it's fixed, it's plus 2. And what is this? This is one of those ones with a variable number of oxygens. We had to deal with one of them here. But this one has
Perchlorate.
It's perchlorate. So it'd be, so what would I call this? Calcium perchlorate. Okay. Now, the next one is an acid. So that means I'm going to have it in what?
Aqueous.
Aqueous. It's going to be in water. And is it what kind of, what do we call this little subcategory of acids? It's a, well, yeah, we'll talk about that later, but well, how many elements are there? What do we call those? It's a binary acid. So this falls into the category of binary acids, hence the hydro prefix. That hydro prefix means there's only going to be 2 elements there. One of them is going to be hydrogen. So pretty much, what's the other one? Iodine. So this one's my favorite. Hi. But I got to make it aqueous. If I didn't have the aqueous, what would it be called? Hydrogen iodide. Right? So the nomenclature gets clearer with practice. Now the next one, PBr3. This is an example of a molecular compound. Molecular compounds are combinations of non-metal, non-metal. And non-metals readily form compounds with other non-metals, if you'll recall. The covalent compounds. And then we have to take the most metallic of the elements present, and that metallic character increases as we go to the left, and as we go to the left in terms of the group numbers, and also as we go down within a group. So in this case, which is further to the left? This is group, what group is phosphorus? Group what? Group what? One more time. Look at the periodic table, group 5. You'll have a periodic table, by the way. That's the only thing I'm going to let you have. I'll provide you with one. And bromine is group what? Group what? 7. Okay, so which one's more metallic? The phosphorus. And so what we do, this is where we're extending the theme. There is a logic to this nomenclature which does make it easier, and so when we extend, we're not having to bring some new weird principle in to bear. Okay, and it also points, when we go to draw these things, it's going to be a little bit easier too, because the most metallic is going to turn out to be the central one. Is going to be surrounded by the less metallic elements. But in this case, we give it the element name of the most metallic element, and then we give it the STEM-IDE protocol for the less metallic of the elements, and it is going to be using the Greek prefixes to denote how many of the less metallic element are there. Or how many of, I'm sorry, not necessarily less metallic, how many of each element is there is taken care of with a Greek prefix. Only if it's the first element is only one of them, we'll drop the mono prefix there. But if the less metallic element would be, there's only one of them, we would keep the mono prefix. An example of that would be carbon monoxide. And then in the case of carbon monoxide, I just want to point this out also, in order for it not to sound too Hawaiian, which monooxide has too many O's in it. Monooxide. Okay. So we drop the O. It'd be carbon monoxide. We drop the superfluous O. Okay? In this case, the most metallic is phosphorus. So we give it that element name, and then how many bromines are there?
3.
So what's the Greek prefix for 3? And we use the STEM-IDE protocol for naming the less metallic of the elements. And there is going to be a couple of exceptions. I probably will cover these in lecture. I know I will cover these in lecture tomorrow. And the problem is we don't have a periodic table handy for me to point to. The exceptions being which one comes first. Hydrogen is considered more metallic than oxygen, so you see H2O. But you notice but it comes between group 5 and group 6. It's hydrogen. So if it's ammonia, like NH3, hydrogen is less metallic. So we have an order of precedent, which I will show you in class tomorrow, and I'll have a periodic table to point to. So it's NH3, but it's H2O. So oxygen, hydrogen is considered more metallic than oxygen, but less metallic than nitrogen. So that division comes between group 5 and group 6. Okay? So it's NH3 for ammonia, pH3 for phosphine, etc. It would be H2O for water, H2S for hydrogen sulfide, etc., etc. So that's the way we write them when it comes to writing the most metallic first. And then the other exception would be with fluorine. It's going to be it's going to give a higher precedent than oxygen. So it'd be F2O, not OF2. Okay, and so that's about it. And oxygen is given a lower precedent than all of the other halogens. So it's ClO they're all considered more metallic than oxygen, okay? So those are the exceptions. This is a lot easier to understand when I got a periodic table to point to, which I will tomorrow when we cover this, because we just were at that cutoff point with the molecular compounds today. Now, so we're back down to nitrous acid. Since this is an acid, what's it going to have? It's going to have an aqueous in parenthetic suffix, and it's nitrous, which reflects what? It has, well, yeah, but it's got the fewer of, there are two possibilities with nitrogen. It can be NO, for one ionic compound's NO3, nitrate. NO2 is nitrite. And since this is an acid, we take the ite and put an us suffix there. And so nitrous acid, nitrite ion. So it's, and we write the hydrogen first. Well, let me change colors. Because the hydrogen is considered more metallic when it's the acid. It's H in how many oxygens? O2. And it has to be aqueous. Now, SO3, what kind of compound is this one? A molecular compound. It's composed of two nonmetals. Non-metal combination. This, I'm just going to use the simple Greek prefix, and since there's only one sulfur, it's the first element, I don't need to go monosulfur. So it's going to be sulfur, how many oxygens? What's the sulfur trioxide? Okay, and the last one is copper 2 sulfate pentahydrate. Again, what is the charge on a sulfate ion? 2 minus, right? And what's the charge on the copper in this case? +2. So what's the ratio going to be, a copper to sulfate? 1 to 1. So it's copper, sulfate, and then I have a big dot here that's right in the middle. And penta refers to what? How many? 5. So I have a big 5 and then water. That's copper sulfate pentahydrate. And that is that's the 10 nomenclature examples that we have on the practice test. You can expect 10 nomenclature questions on the real test. Question? Okay, were you asking a question? What, you're next. Did you have a question? Yeah. What? I misspelled sulfur? Oh. Did I? I did, didn't I? Thank you. Thank you very much. I did not do that. I could sit up here and lie to you guys and say, well, I did that to check and see if you're a pen. No, I didn't. I didn't do that on purpose. I actually made a mistake, and I have the advantage here. Thank you. Okay. Now, what was the other question? You had a question?
How do I know for I it's not sulfite?
For I, it's not sulfite because it's not an ion. It's a molecular compound. If it was a molecular ion, it would have a charge, and it'd be. I could ask you to name an ion, but I don't have any examples with that. They're all compounded and electronically neutral. But this is just a non-metal combination. It is distinct. It is not the same as sulfite. That's a very good point. Okay. Any other questions before we move on? Okay. So that brings us to wrap that.